Characteristics of gases. The gaseous state is characterized by extremely weak intermolecular forces between the atoms, ions, or molecules because the distances between the gas molecules is usually quite large. For gases, we say there are essentially no intermolecular forces. Again, looking back at Coulomb's law, since R is in the denominator and R tends to be very large for gases, the forces go towards zero. Solids, they have strong bonds, and liquids, they have stronger intermolecular forces than do gases. Since there are very few attractive forces between gas molecules are free to move and will expand to fill their containers. Look here, we've got gas particles. You have a piston in a cylinder, just like in a car. Move the piston up, and the gas particles fill the container. Liquids, you pull the piston up, and the liquids will be affected by gravity and will stay at the bottom of the container. So let's take a look at some comparisons. Since there are very few attractive forces between gas particles, small numbers can occupy a very large volume, meaning you have a very low density. Let's look at densities of ice, water, and water vapor. Normally, the solid would be a lot more dense, but because of hydrogen bonding, ice is slightly less dense than water. The result of this is that ice floats, and this is why that you can walk across a frozen lake or frozen river, because as it freezes, the ice floats to the top and creates a barrier between that surface and the liquid below. But once we get out of the liquid phase into the gas phase, the hydrogen bonding is no longer a factor because the molecules are so far apart. And the density plummets almost 10,000 times. Note that water vapor is over 1,800 times less dense than water. Obviously, my math is a little bit off, but the point is clear. Water vapor is way, way less dense than is water. Now, since gases have such low densities, meaning fewer particles in a very large space, they can be compressed into a much smaller volume. And when a gas is compressed, the particles are moved much closer together. For example, a turbocharger compresses the air before it enters the car or jet engine. And even in a regular car engine, what happens is the pistons push the gases down inside the cylinder, compressing the gas, and then when it's ignited, it creates a much stronger reaction because so many of the gas particles are so close together.